We create our first circuit. To do this we take a switch, a lamp and a wire. We move the switch and lamp and adjust the wire. As we can see, the state of the switch changes as expected. But nothing else happens yet. First we open the component class. In the constructor we first save the Blender object passed on. Later we will add the connected wires. We first calculate the vertices and then the boundaries of the object. The first attribute is not needed for now. In this method we move the vertices from the local vector space to the global vector space. To determine the cabling we need the positions in the scene. Here we then calculate the minimum and maximum coordinates. For the sake of simplicity we consider all components as cuboids. Finally, we add an output that we use to check the determined values. We switch to the wire class. Here too we save the Blender object. All connections to the components come in here later. Here we are looking for all endpoints of the wire. And here we look for all connections to these endpoints. In this method we move all points of the wire from the local to the global vector space. We save these points as endpoints. Here we go through all the components and if the point is within that component, it will be added to the connections. In the component class we add the wire. Now we switch to the switch class. Here we change the idle method. The status of the switch is passed on to all known connections. In the wire class we create a new method. Here we adjust the status. When the data is updated, the object is adjusted and the material is also recalculated. We test this and see that the status value of the switch is passed to the wire. We now go back to the wire class and adjust the change state method. We pass the status on to all connected components. Now we adjust the lamps and add the set state method. Here we take the status and update the object. Continue to the component class, where we create the set state method. We now test again and find that the status is now passed on from the switch to the lamp. Checking the accuracy of our entries is very easy here. There are only two options. Later we will get to know circuits with significantly more variance. We still need a way to test this. To do this, we start Blender and load our circuit. We switch to scripting and create a new script. As always, we import BPY. Then we create 3 global variables. Now we create a method that should be called before every frame. We test by frame. At frame 0 we look for the object with the name A. The switch has been given this name. We change the status of the switch. We now have to wait at least 1 frame for the changes to be processed. Therefore, we look for the lamp named B in frame 1. We check the status here and issue a corresponding status message. The rest just lets you update the frame variable. When we have changed state 4 times, we remove the method from the list of handlers. Now all we have to do is add the method. We start the circuit and then start the test script. As we can see, the status is changed. And the output tells us that the verification was successful 4 times.